So in the ER model, it will be very different. And let's assume based on the ER diagram we showed before, it's like this. You know, in the next section we will cover. In the next section we will say. In the next section we will introduce that we need to translate everything here into relations, beer, L, as well as subclass. And we can show you the translation first, and after we do the translation, we can create two relations. It's different from relationship, right? Relation is another concept we will cover in the next section. And after we do the translation, let's assume we have two relations. The first one is beer. This denotes the relation name. Inside it, we have two attributes. Name, its type is char and 30. It denotes it as a string. Max length is 30. And we also have a manufacturer. It's also char 30, like this. Then we can create one relation for beer. Since beer is a subclass, it's very simple. It has only two attributes we show here. And let's come to the L. This L is a subclass. It inherits from beer. According to the ER diagram, it has only one attribute, that's color. So then we can create this L, and we can have a color. This char, for example, char 10. This is entity L, right? According to the ER diagram we see here. However, this L is a subclass of beer. And in our translation for subclass, the rule is very strange. The rule is very special. Besides the information or attributes from L's, we also need to take the key of beer into this L, this relation as well. So therefore, here we assume that for the beer, this relation, we can take this name as the key of the relation. It can differentiate different beers according to the name. And since this L is a inherent subclass from the beer, in the translation in two relations, we also need to add this name into this L as one actual attribute. It will indicate this L is a subclass of beer. It inherits this name here, of the beer name here. And we will introduce the details of the translation in the next section on the ER model, on the relational model. So if you cannot follow this, it's okay. Let's assume we just have two relations like this, and we want to insert some data into this L's table. So for each of the relation, we will create one table, and I can show you the table here. This time we have a table for beer. It has only two columns, and each column denotes a attribute. Let's assume this is the beers table. We know in the beers table we have two attributes. The name is the manufacturer, right? And this L, we will also create one table for it, and we can copy this directly. This is L table. Inside we have two attributes, name as well as color. So you see, this L is a subclass of beer. However, its data is stored into two parts. One part is in here. It covers the color information. One part is here. It covers the name and manufacturer. How can we indicate like this L is a subclass of some beers? Then we can use the name as something like a reference or the key. So based on this name, we can know which a tuple should belongs to in the beers table. I can show you one concrete example. And let's assume we want to do one operation to insert some data. Then we can do this. Let's assume we want to do some insert. Insert into L with the data as shown here. I can use a large font to help you see the statement. We want to insert the else table with some data tuples. For data we have, the name is myL, manufacturer is my home, color is night yellow. How can we insert the data into tables, as shown here? For the object-oriented programming, we see that for the subclass, its attributes, they are all organized in one memory space. However, for the ER model, once we insert some data into the tables, the data will be divided into two parts. The first part will be the attribute we have for the else. Now here we can still have this night yellow and its color. We insert here for night yellow. We can use a small font. Open write down directly. Once we do the insert, we can add the night yellow as the attribute for the color. We can say it's night, right? As to the myL and my home, they will be inserted into beers. Because we find that L is a subclass of beer, then this kind of information or attribute will be inserted here instead. Since it is a subclass, we also create one extra attribute name inside its else table. It will be the same as the name we show here. In other words, we also need to add this myL inside its else table. It will be like this. So you can see for subclass in the ER model, when we store the data into the database tables, the data will be divided into two parts. So here we divide the color here and name manufacturer into beers table. And to do the referencing between else and beer, since it is a subclass, we add one more attribute name here. This name is a key for beer. And we add one more attribute, myL, into this else table. So the data will be divided into multiple tables in the ER model when we're storing the data. I hope it can show you the difference between the subclass in the ER model versus its object-oriented programming for you. I hope this example can show you the difference for the subclass we learned from the ER model.